I'm sure I can get started. I don't know who's in charge of Code Blue, but I think that I could probably begin. I've got a lot of things to show you. I'm very excited to show you. So welcome to my Blue Box. As I go through this, after we finish it, you can feel free to come up and look inside, and you can take pictures. You can take pictures of this as well, so pictures are fine by me. So thank you so much for your interest and for coming. My name is Mike Spicer. I'm also known as Dark Matter on the internet. I'm really passionate about wireless. I think of myself as a mad scientist, and also I think of myself as a hacker and creator. These pictures that you see on the screen right here, one of them was from my talk. I did a talk at DEFCON this year on the main stage there. And then the one on the right-hand side is the picture of my new project, the WifiKraken, which is this is the second time that I've presented this project. So this is the new system that I'm very excited to show you. Also, if anyone has questions or things throughout the presentation, I want this to be interactive, so feel free to raise your hand and ask questions. So this all started with me being curious. I started off being curious and wanted to know what's going on the Wi-Fi. And the box on the left was my very first project. It was essentially a Raspberry Pi with two wireless radios. And you can see the wireless radios. One is here and one is here with some batteries. And I put that in my backpack, started carrying it around with me. And then I was able to collect some data, but I learned a lot of lessons from doing that. And I didn't catch very much data. I was missing a lot of information. And the reason is because I was using the wrong software. So it was very much a lesson to me to use the correct software and hardware together. So that project turned out to be a little bit bigger. So if you look on this other side, I then built, with the help of my friends, all of these boxes. So it was a big improvement over the previous one box in my backpack. And we ended up placing those around a conference, DEFCON in Las Vegas, and also Black Hat in Las Vegas, and deployed those sensors throughout the conference and gathered data there. This was a very big learning experience because, first of all, they were little suitcases, and security was very concerned that they could be some sort of harmful devices, maybe bombs. So it was interesting. Only one, though, got confiscated, and I ultimately got it back after I explained what the project was. But it's interesting when you're putting things around places, people start to notice them and want to know what's going on with your boxes. So I have been around the world. This is my first time to Japan. I'm very excited. This has definitely been on my my bucket list, my lifelong goal list to come to Japan. So thank you so much for having me. It's absolutely been a pleasure. I love it here. But as you can see, I've been with the Wi-Fi Cactus, my first project, to all of these locations. And there's still more I want to go to. So, and I'm very happy to add Code Blue here on this. This has been an absolute treat. So thank you so much. You might have seen me with Darrin Kitchen on the episode of Hack 5, if you're familiar with that YouTube channel. Darrin and me are really good friends, and he actually provided me the main devices, the Hack 5 Pineapple Tetras that make up each of the devices that are being used in the Wi-Fi Cactus. There's 25 of those in the Cactus, and so it was through a sponsorship through Hack 5, so I'm very appreciative to them, and I've been on the show a number of times and done interviews. Last year I had the opportunity to go to DEFCON China for the first time for its beta rollout, and that was very interesting bringing this to China. So yeah, it's very interesting bringing that to China. But I made it, and everything is okay. Now I'm here to talk to you guys. So I learned a lot of lessons, I learned a lot of things from building these different projects and building these things up. And the things that I learned is that I need to get more throughput. So one of the disadvantages of the Wi-Fi Cactus, let me just give you a quick introduction on the Wi-Fi Cactus. It's made up of the 25 pineapple tetras, the Hack5 pineapple tetras. It then takes all that data and it takes it over Ethernet and brings it back to the Intel NUC at the top. So this is an i5 Intel NUC 8th gen Intel chip. And then it also has an NVMe storage device, so for hard drive. So that's all coming back through Ethernet. And these are gigabit switches, 2 gigabit switches. And I chose these switches because they support DC input, DC power. So the data is coming from all these aggregated through the switches to the NUC. So that means that I have a single 1 gigabit bottleneck on this system. And I wanted more because if you look at the capability, each of these devices has 2 wireless radios, and essentially each of those wireless radios is capable of doing up to 600 megabits apiece. So 2 radios can saturate the gigabit, depending on how busy the environment is. And so as I'm aggregating the data back, I'm going to inevitably have loss with this. Oh, another thing too is there's this cool board right here. This board, it's an antenna aggregator, or a signal aggregator. So it's taking the input from 2 signals, 2 antennas, and it's putting it out into 8 radios. And so it reduces the overall number of antennas. This originally had 100 antennas, and now it's down to 86. So we're making progress. Let's see, the other thing that I've upgraded on this, in the first iterations of it, I was using a lead acid car battery, which weighed about 8 to 10 kilos, right? Is that right? No, yeah, 8 to 10 kilos for a total weight of about 30 kilos. And so now I've changed those to lithium ion, and now that's approximately about 15 kilos now. So it's a lot less weight and makes my back less sore. And I can carry it around longer. Also, the duration is up. It only lasted about 30 minutes with the lead acid battery. With the lithium ions, it's about 3 hours of runtime that I could walk around, I could go places. So, yeah, I'm actually gonna see about maybe walking around the streets of Tokyo. Do you guys think that that's a good idea? The consensus is yes. Thank you. Also, one other thing at the bottom of it is I do have an AC power supply, because sometimes when I'm doing presentations or demonstrations or have it sitting someplace for a long time, it's nice to have it plugged in so that way I'm not just using the batteries. Oh, and then I do have an Arduino here. The Arduino is powering the lights. These are NeoPixel lights from Adafruit. So you always have to add lights to your project so that way it looks pretty. It's important to have pretty. And then the pineapple on top is homage to the Hack5 pineapple tetras that this device is made up of. So, yes. And now, thanks to my friend Kentaro, who is one of the hardworking organizers at this event, there is now a duck on here as well. So, thank you, Kentaro, for the duck. Duck Army. Okay, so that is the Wi-Fi Cactus. And then the lesson learned from the Wi-Fi Cactus was the throughput and bandwidth issues. So after this is over, feel free to come up and you can take a look. But essentially what I've done is I've got less radios. So this is 50 radios. This one only has 14 radios. So it's a bit less radios. But each of the radios is going to a unique, to 2 different unique USB 3.0 root hubs. And I'm doing that by having 2 USB to PCI Express 7-port USB hubs. So I'm able to get more throughput from the adapters directly to the solid-state hard drive. Which completely bypasses the Ethernet issue that I was having here. The other thing too is this device, the Hack5 Pineapple Tetra, is a fantastic device. However, it uses only the 802.11n wireless radios. And more recently, we're already on Wi-Fi 6, which is 802.11ax, and I'm not there yet. So my next project will be an 802.11ax project. This project is 802.11ac capable. So the chipsets in this, the wireless adapters, are called Mediatek MT6752, and they have built-in Linux kernel support beyond kernel version 4.30. Now the advantage of that is you're going to be spending a lot more time capturing data, as you can see from the screen, as opposed to fighting with drivers and trying to make changes and compile. And I've ran into a lot of issues with drivers, and so it's very nice to have these working. So if you want to do wireless monitoring, this is definitely the best place to start right now. Is the Mediatek MT7612. I really love those. So the pictures that you see in the middle there, this is the logo of the Kraken on the left, and the middle picture was the first time I had taken this. The other advantage of this is I close the lid, I lock the locks, and then I check it at luggage. And then it ships with me, and it's easy. This takes about an hour and a half to disassemble everything and put it into 2 separate cases, because by itself it weighs too much to travel with. So it's this one is a lot easier to travel with. Also, it too is battery powered. There are these batteries called Talent Cell batteries. Yeah, I'll just have to come up and look at them. Essentially, it gives this device about 3.5 to 4 hours of runtime on those batteries. And they're also rated at just under 100 watt hours, so you can bring them on a plane. So, and I have 3 of those, and I brought them here with me on my flight from the United States. Okay, also, the picture on the right that you see there is at Black Hat in Las Vegas. I was able to set this device up and was able to monitor the traffic for a number of hours and days there. So they've always been so great to me and allowed me to set up my projects to be able to do analysis there. And so it gives me a lot of opportunity to get data. And if you can see the monkey right there next to him, Lyle, he's the Network Operations Center monkey, and so he's always there and interested in my projects. I'm going to do some live demos. We're going to get into some live data of what's going on in the environment around us, but first I wanted to show you some of the data that I've captured in the past. So being able to go around the world and travel to different conferences, it enables me to do graphs like this. And what this graph shows is each of the small dots is a unique MAC address. And so this could be of your cell phone, this could be of laptops, this could be of different devices that I see in the environment, and I'm taking that MAC address and I'm correlating it to the different locations where I've seen them. So for example, you can see Black Hat in 2017 to Black Hat 2018. You can see the lines in the layover where there's the correlation, and there's the, oh yeah, I've got a mouse pointer. You can see the group here, the grouping. So these are people who have gone to both of those. And so I'm essentially filtering by edge nodes greater than 2. And then also we can see that there's a lot of people who came from Black Hat to DEFCON 2017, and we can also see this one is interesting, DEFCON 2018 or DEFCON 26 and DEFCON 25. So there's a big clustering of people who went back the next year. So it's interesting to be able to see this. And of course you see this huge following from Black Hat 17 to DEFCON 25 because it's at the end of the week. So I anticipate here I'll see some people at Code Blue that hopefully I'll see also at Tokyo, AV Tokyo. So we'll see something similar on this type of graph for next year. And so it's really neat to see this, and it really gives us a sense that our community is global. I see very similar people at all of the different places. It's really neat to see the community and the globalness, and to see kind of the mapping of how this all comes together. Another interesting thing is the data leaks. That's one of the most fascinating things to me. We look at apps and we look at our websites and things, and luckily our websites have the little lock, right, that tell us that there's SSL happening and that things, or TSL that's happening, or TLS that's happening, and that we have some level of encryption, right? But apps, there's no way to see that. There's no information that says this communication is happening encrypted. And here's an example from the DEFCON 26 data set that I had, where a ZTE phone, and it was a desktop weather widget, which had access to the phone's geolocation, was doing an API call over HTTP with no encryption. So, and if you can see, oh yeah, I've got this. I keep wanting to go over here. I keep wanting to Vanna White. If you can see the latitude and longitude there, that's a part of this. So I've essentially gotten this device's MAC address, and I've got their latitude and longitude as soon as they make the post request to the API. So what could go wrong with that? Essentially, it's a people tracker at that point. So anytime that person is looking for their weather, and this could be something benign as I want to know if it's going to be rainy tonight, it's leaking my information. And in most cases on phones, that's privileged information. You have to specifically say, I give permission to my location data, right? Because location data is privileged information on most devices now. Also, when I checked this data, that API call is still valid, so you could type that in on your phone right now and get the weather for that location, and it's still using HTTP. So I'm concerned that people are still doing things unencrypted. So yay for information leaks. Here's some of my contact info. I just want to give that to you guys right now. We still have some bit more time. I'm going to go into the actual software and go to the live demo portion of this. But yeah, feel free to take a picture of this, and then in a moment I'll bring this back up. I also wrote a tool called PCAPinator on my GitHub, and basically it's a tool to parallelize PCAP analysis. So it tears a PCAP into multiple pieces or breaks it into multiple smaller pieces, and then it will then process those based on how many cores you have on your system, and then we'll reassemble the results at the end. And so it's a very useful tool for when you're dealing with large amounts of data. Like my data collection from all the different locations has been way over a terabyte at this point. So lots of data. Okay, let's take a look at actually the software. So first off, I just wanted to do a shout out. Okay, so we've got two different services running. So we've got the WifiKraken. So this screen we're looking at right now is the WifiKraken. It's this one. And then we've got the Wi-Fi Cactus, and I'll show you that one in a moment. So this screen that you see on right now is a mobile dashboard developed by your own El Cantaro. He built this, and it's on his GitHub. The software that I'm using is a software called Kismet. Have any of you heard of Kismet? A couple of you. So Kismet is turning into a wireless analysis software, completely open source, free to use. You can install it on your laptop, and this is what you end up getting. You're able to then see what's going on in the environment. The red, don't be worried, the red isn't anything to be concerned of. It just means that we have captured the WPA handshake. And I've been able to monitor and watch the communication enough to be able to get the WPA handshakes on each of these access points. So that's cool. Back to the dashboard. Kentaro made this dashboard, which is super handy and provides summary information for what's going on in the wireless around us. So right now, this device is seeing 89 active channels. I do have 13 out of 13. This actually does 14 devices. I've only got 13. One of them's being a little finicky. That's one of the problems of using USB wireless devices, and so many of them, you get a little bit of issue, and so 13 are active and working right now. The 14th is not, but we're seeing data on 89 channels currently. We're recording data at about 3 kilobytes per second, or 3 kilopackets per second. And then also, I've seen so far 24,000 unique devices in the environment, which is a lot of devices. And so we're probably seeing also devices of people driving by. We're probably seeing people up above us, below us, you know, people all around us. We're probably seeing a lot of additional communication, because wireless is magical and it just goes everywhere. It's all around us. It doesn't stop at walls, right? At some walls it does if they're concrete and lead lined, but for the most part, we're able to see wireless all around us. And this can pick up basically for around 100 meters is what it's capable of seeing. We can also see which channels seem to have the most devices on them. So we can see here, it looks like 5.18 gigahertz has, 73, and we can also see as people are moving around the building, it's going to change because of what access point they are on. Also, if you're using something like Aruba or something that has like the Cisco Aeronets that have cloud controller, it's actually going to strategize your wireless access point channels throughout the environment as the environment changes to try to offload load to make sure that areas are getting the best throughput that they can. And so it's really nice to be able to have this many radios so that you can watch those types of things happen. You can see what's going on in the environment, watch those transitions happen, and be able to capture that communication. Let's see, it looks like currently we have 485 unique access points in the environment. Like I said, we've got 22,000 clients on those access points or that are client devices. And then we've got, what are these ones? So here's, let's see. It's so many, it might take a moment to load. We'll leave that, let's see if I can open a new one. Yeah, there we go. Okay, so, and we can start seeing all of the individual devices that are listed in here. We can immediately click on a device. I don't know whose device this is, but we can get some basic information about this device, who the manufacturer is. This based off of the MAC address. This one is currently unknown. And we can see just some base information, so it's really nice. Kismet, so this information is pulling from Kismet using the APIs. Oh, interesting. Server crash. Wait, no, it's still running. What in the world? Okay. There we go. Okay, I just need to reload the page. So this is the full UI. So that dashboard I was showing you was just a plugin that Kentaro had made. This is the full UI, the full user interface for Kismet. And basically the creator of Kismet has done a really good job of allowing us to quickly access very important information about our network. Whether you're a blue team or if you're doing red team activities. So a red team type of activity would be trying to capture the handshake or trying to understand what clients there are and try to enumerate or get information about who's in the environment, and then figuring out a way to manipulate them into connecting to your own network, man in the middle them, or maybe denial of service, so then they'll connect to something else. You'll want to do those types of behaviors as a red teamer. And this tool allows us to quickly figure out that type of information. So let's click on an access point. This one for Code Blue currently has 693 connected devices. That's a lot of devices on one access point. We can see that the majority of the communication is happening on 526 and a little bleed over onto 528, which it's probably, it might be a 20 or 40 megahertz channel width. I'm not sure, I'd have to look at the packets. But we can see the majority of the communication is data packets. And so based on that, we know that people are using that and getting a lot of communication, streaming stuff, probably pulling up things on their phone. And then there's the LLC or management frames, which are telling how the communication works. And that's a much smaller portion. So if someone is doing bad things, if somebody's trying to hack this or do something, we might see these LLC frames much, much higher because that would be someone trying to do like a deauthentication attack or man-in-the-middle attack, or trying to do something to you to try to convince you to connect to their stuff or to get you to disconnect. And that all happens at the management level, so we would see a significant portion of the management frames. But this just looks like people are using the Wi-Fi. So use on. And then here, if we look at the 802.11, we can see that it's the SSID has been beaconed out as this. This is the BSSID, which is the MAC address of the broadcasting radio. We can see that it's beaconed a ton of times. So we know that that's happening. We can look at the different types of packets. We can see if there's been data, or if we've got fragmentation, or if we have retry. So that could be something that blue teamers use, or just your IT staff use, to be able to do analysis on your wireless infrastructure. Perhaps your wireless infrastructure is struggling, you're having slow bandwidth, you're having issues. You can see all of that with an external tool now and be able to determine that and be able to track down those issues. Maybe it's a specific client that keeps having a lot of retries. We'd be able to track that down. Like I said before, one of the most handy things is to be able to do the WPA, be able to capture the WPA handshake. And since it's highlighted in red, that means it's already accessible. And since it's accessible, I can just one-click it, download it, and pull it open in Wireshark just that quick. And this is the EAPOL of the handshake that took there, that I captured. And so from here, it's now one step to be able to take this and put it into Hashcat to be able to begin cracking it. So if I was doing a pen test on this infrastructure, that quick for me to get this access point and try to get the password. So that's why I always recommend, if you do use WPA Personal with a passphrase, make sure that it is at least 12 to 15 characters, to 12 or longer characters, so that way you're able to avoid someone like me that's going to crack your network. Also, we can see channel utilization, so we can see how much wireless is based on the QBSS, see how much the clients are communicating at a single time. And as you can see, it is doing HT40 mode, so that means it's 40 megahertz channel widths on this channel. We can also see what the beacon rate is. We can, just lots of really cool stuff we can see. We can also see what the country code is set to. Obviously, we're in Japan, but that's useful for, let's say we're in the United States, and someone has their country code set to Japan, and there's specific channels that are illegal to broadcast on. I could then detect that just using the software here. And then in addition to this, we can also see shared hardware. So this means that these are access points or devices that are likely connected because they're doing similar types of behavior. So for example, they're doing virtual access points, as far as I can tell, with the Code Blue private, Code Blue, the free Wi-Fi, and the Koroke. I don't know how you say that. But essentially, they're all seemingly coming from very similar MAC addresses, this 004E CB43, and I believe that's Aruba MAC address. If we go and look at the view, the AP details, it's saying Hewlett-Packard, but I do believe HP bought Aruba or something like that, or somehow it's in the OUI for that. So we can now look, like I just took one hop over, and we can look at this device, see what it's beaconing, see what's happening, and then see what the analysis is on this access point. So it's very handy, very useful for breaking down and doing the analysis. We can further then look at the different clients. So we have Wi-Fi behavior, which is when you have a client using multiple networks over time. And it's also nice, there's all these little help buttons, so if you don't know what something is, you can just click on it too. And we can also see the associated clients. So these clients are like clients that are roaming, and these clients are like our phones, laptops, and all sorts of devices that are connected. So let's say that this device is causing problems. We can immediately click View Client Details. We can add a note that potential issue. And then we can save that note, and we can now keep track of who this is and what they're doing. And we can see then, if we look at the 802.11 graph here, let's see what it's done client behavior to all of these access points. Okay, so what are these access points? We didn't capture which one that one was. We're not sure which one that one was. And see how it's 0 bytes? I just saw them beaconing or communicating, but I didn't actually see any data communicated throughout them. So this one's actually kind of a bad example. Let's see, let me pick another one at random. 28, that one looks good. Intel, let's see, what is this one up to? Here we go. So this one probed for code blue, and it also probed to broadcast. So this one, based on probing to broadcast, it might be susceptible to a karma attack or basically a man-in-the-middle attack where I could set up an access point because it basically is broadcasting and probing and saying, hey, is any network available that I want to connect to? And so that might be a device that we could manipulate if you were trying to do man-in-the-middle attack on that. Okay, let's back out of this just a little bit. And so I'm going to show you, we already saw the devices, the data sources, so we can see that the 13 devices and which devices are pushing the most traffic. So one of the things I've done is, based on the environment, I looked at the number of clients that we have, and I looked at the channels, so channel 52, 132, 60, these ones are pretty heavily used channels, so I decided to fix some of the channels. So some of the radios are bouncing between channels, or channel hopping is what it's referred to as. And then I've fixed some of these others. You can see this one here is fixed, and this one here is fixed. So basically what that means is I'm going to be listening on those channels constantly so that way I get the most amount of information. And so the advantage of that is that I can get more communication because it's not switching channels. Because every time you switch channels, you're going to miss out on some of the communication. So that's one of the new things that I'm working on. I'm actually, last night, with Kintaro's help, started building a script where I want to do this automatically, where I'm able to do the auto-identifying of a network, identify the highest used channels, and then have it switch maybe 3 or 4 radios onto the top highest channels so I can get the most amount of data captured for my analysis. Because that's always been an issue, and I'll show you the reason why. This is the Wi-Fi cactus now. We'll look at the same graph, the channel hopping. So it's a much bigger swath of connection that's happening because currently there's 48 radios that are active. 2 of them are not up for some reason. I'm not sure what's going on. Looks like maybe the top one is kind of sleepy. So basically there's 48 radios currently out of the 50 that are currently capturing things. The goal with the cactus was to not have any radios to have as much wireless spectrum coverage as possible. And as you can see, if we compare this channel hopping graph to this one, it's quite a difference. Let me zoom in. There we go. So, yeah, so the cactus solves that problem. But like I said before, the problem is with the cactus is the bandwidth limitations, the throughput limitations of the Ethernet ports. So, all right, let's see, how are we on time? I think I've got 20 more minutes, is that right? 12:30 something? Okay. All right, so on the Wi-Fi cactus, so essentially we've got the same type of interface here, but I'm basically capturing data at a much higher rate because of all of the radios that are in here. And so, let's see. The other thing too I want to show you as well, down here in the messages, we'll see if anything pops up. Kismet also has built into it something called Intrusion Detection System, or IDS. And there are certain signatures that it's built to identify. Some of those signatures are if someone does a man-in-the-middle attack, or if they do a deauthentication attack, let's see, what are some of the other ones? If someone were to launch a cracks attack, cracks the key reinstallation attack, it will do identification for that. Broadpone, the Broadpone vulnerability, wireless vulnerability, it does have support to identify that. It also looks for other weird things, weird cases too, such as if someone uses an SSID that is longer than 32 bytes, that's something that it could show malformed behavior, or it could do some damage because that's longer than the spec. And so that's a way that it can be identified, and to see if someone's trying to do something tricky. Maybe they're trying to do an injection based off of SSID. Yeah, so for example, right there, we just got a nonce. It went by too quick. There's too many devices. I'll have to go back and look in the logs. Basically, that was I believe it was a nonce recycle, so that could have been legitimate behavior of the a wireless access point renewing its encryption. Or it could have been somebody doing it on purpose. The fact that we're not seeing a ton of them, that's the thing about wireless attacks, they're usually very noisy. They're usually doing a lot of things at once. The fact that we only see it once is probably benign behavior. It's probably something built into the access point. Yeah, WPA, EAPOL, RSN reuse. Yeah, so that's probably just something that's happening with the access point that's throwing out that warning. But if someone had a Ponagachi, has anyone heard of the Ponagachis? Couple hands. I think, do you have one, sir? Not yet. Ponagachi, essentially what it is have you heard of Tamagotchis? Of course you have. It's Japan, right? It's this cute little device that was created to do deauthentication attacks as you walk around. It uses a Raspberry Pi and ink print screen, and it's got a cute little face. And all it does is deauthenticate a wireless network and then capture the handshake. So, silly people. And so if someone were to bring one of those in here and launch that, our Wi-Fi might stop working, but I would be able to see that that attack took place. So I'd be able to see a Ponagachi take place in this environment. Okay, I definitely want to leave time for questions and for you guys to come up and look at things and stuff like that. So I'm going to go ahead and end the formal portion of this presentation, and then we'll allow the questions, and you guys can come up and look. And I do have some stickers. I don't have enough for everyone. I apologize, but I will hand out as many as I can. And if you're coming to AV Tokyo, I'll have some more there. So thank you so much for your time. I appreciate it. Thank you. Okay, questions? Yes?
One of the first screens you were showing for your data collection, I believe you said it was a plugin. I noticed when you scrolled down, you had a section for Bluetooth. Are there any plans to support Bluetooth or cellular?
I would love cellular. It's already built in. I just don't have the modules activated. I don't have a card for this, a Bluetooth card. You just need a UD100 or just a dumb Bluetooth device to be able to capture it. It's basically looking for Bluetooth and BLE beacons. On the Cactus, I did have it hooked up. I don't have it currently. The Nook actually has Bluetooth built in, but I don't have this dashboard on the Cactus. But that's built into Kismet. In addition to that, you can do RTL 433, so if you hook up an SDR to Kismet, it will start gathering 433 and decode those packets for different IoT devices that are on 433 megahertz. In addition, ADSB was just added too. I don't have an ADSB adapter, but ADSB is the signal that airplanes send out to be able to tell their geolocation, their altitude, latitude, longitude, all of that good stuff, and then it will map it inside of here. So Kismet really is turning into a full wireless analysis software. So through RTL SDR, ADSB, Bluetooth, Wi-Fi, basically the whole spectrum. The cellular is a little bit more difficult to do monitoring on because you need an active connection to be able to do monitoring, has been my experience. So that's an area of interest I definitely am working towards because I get that question a lot, and I want to know what's going on in the cell. So, but I'm not there yet. So hopefully in the future I could have some research in the 4G, 5G arena. It's my goal. So thank you. Other questions?
how much does it cost to build WifiKraken and Wi-Fi Cactus?
Okay. The question is, how much does it cost to create the Kraken and the Cactus? The Cactus was a little bit more expensive, but luckily it was a sponsorship. But the retail cost on that would be about $6,000 US. What is that? 600,000 yen? Is that right? I don't know. I can't remember what the conversion rate is. Something like that. And then this one is a lot cheaper. The motherboard is actually an old 4th gen Intel processor, so that's probably like $50 on eBay. The wireless adapters are about $25 each. So I would say maybe $400 to $500 to build this, and then the case was about $150 for this hardened. It's not even a Pelican case; it's a rip-off case called Condition 1, but it works pretty well. So it's a bit cheaper. The batteries are $45 a piece as well for the batteries. So I would say $500 to $600 to build something like this. And if you want to get started, you could take a laptop, one of these adapters, and run Linux, Pen2 Linux or Ubuntu, the latest version of Ubuntu, plug the adapter in, install Kismet, and you could get started and do the similar things that I'm doing here. So it's that easy for you to start doing analysis on the Wi-Fi.
Thank you.
Thank you for your question. Any other questions? Other questions? Feel free to come up here, and if you think of anything else, just shout it out at me. Thank you so much.